Polygons and angle measurements. Here are a few different polygons: triangles, squares, pentagons, and hexagons. Did you realize that a pentagon could be drawn more than just the way that you see it here? All of these figures here would be called regular polygons. And by regular, I mean all of the angles are the same. But notice how a triangle, by definition, just needs to have three sides. In this case, we have a right triangle, but still three sides. Having said this, a pentagon, as we see here, can also be drawn in another way as long as it has five straight sides that all connect. 1, 2, 3, 4, 5. So here is an example of another pentagon. Let's take a look at a few of these figures to find how many total degrees they have. Now, the very first diagram that we had was a triangle. This triangle has three sides. There are 180 degrees in a triangle. The next figure that we had was a square. I'm going to draw another type of four-sided figure. I'm going to draw a parallelogram. Now, if we add up the four corners of this figure, we have four sides to it. When we add up the four angles, we would get a total of 360 degrees. Now, what about a five-sided figure? Figures that have five sides are called pentagons. 1, 2, 3, 4, 5. And there would be 540 degrees. Do you see a pattern happening between the amount of sides we have compared to the total amount of degrees? For every side that we add, you could say we add on 180 degrees. But there's another pattern here. What if I was to draw a 20-sided figure? Now, I'm not going to try to squeeze it in on this page, but let's take a look. We have 1, 2, 3 sides. So on a 20-sided figure, there would be 20 sides as well. Well, what if I said to you, let's subtract 2 from our sides and then multiply by 180? Well, 3 minus 2 would be 1, and 1 times 180 is 180. What if we take that rule and we apply it to every other example that we have? What is 4 minus 2? Well, that would be 2, and 2 times 180 is 360. And I think you can see where we're going here. 5 minus 2 is 3, and 3 times 180 would be 540 degrees. So in our 20-sided figure, if we apply this rule without even seeing what that 20-sided figure would look like, if we apply our rule here, 20 minus 2 would be 18, and 18 times 180, well, that would give us 3,240 degrees. And remember, these degrees here represent the three angles inside of the triangle. The 360 degrees, when you add all four angles on the inside of the parallelogram, they would equal 360 degrees. 540, and so on, when we added the 5 angles on the inside, it would equal 540. So when you added the 20 angles of our last figure, our 20 sides, so we have 20 angles, all 20 angles would add up to be 3,240 degrees. Now, we said 3 minus 2 was 1, 4 minus 2 was 2. Let's take a look at why we were doing that. Well, we have three sides on our very first figure. We have three sides. We have one triangle here. What happens when we take our four-sided figure and we break this into triangles? Let's connect opposite angles here, vertices. How many triangles did we just create? 2. Well, if we know that one triangle has 180 degrees, and over here we have 2, I suppose I should label that correctly, 1 here and 2 here, well, 2 triangles times 180 degrees is 360. What about a five-sided figure? Well, we just need to go corner to corner, So there's one triangle. And when we go corner to corner, there's two. And oh look, we made a third. So 3 times 180 gave us 540 degrees. Now what about a stop sign, an octagon? For this stop sign, we have 8 sides. Now when we break apart a stop sign, we have to go corner to corner. You could start by going diagonally across. But we could also connect a whole bunch of other pieces without overlapping lines. That's our last rule. We cannot overlap or slice it like a pizza. We cannot cross over any lines we've already drawn. So there's one triangle. And now we can't label this a triangle yet. It has 1, 2, 3, 4 sides. So we could connect yet one more set of angles there. So we have 1, 2, 3 triangles so far. Now we could start from this bottom right vertex, and here's a 4th triangle that we made. Slice one more time. Here would be a 5th and a 6th triangle. So think of our rule. You count how many sides you have. We had 8. And if that rule was -2 and then times 180, we would be doing 6 times 180, and that would mean that this octagon, any stop sign, has 1080 degrees in it. Let's apply these rules now to a little bit of math and calculation. Now we know that a triangle has 3 sides, -2 would be 1. So 1 times 180, this is why a triangle has 180 degrees. So if we take this triangle and we say, hey, there's 180 degrees in here, well, let's subtract out the 2 pieces that we know. Let's subtract 55. Let's subtract the 80. Let's get rid of these from the 180. And if you do 180 minus 55, you get 125. And 125 minus 80 more, subtract 80 more, we find that we have 45 left over. And that x equals 45 degrees. In our next example, this isn't a rectangle, it's not a square, it's a quadrilateral. It's a 4-sided figure. So when we look at this image here, we know 3 of the angles, and we're trying to discover the 4th. Well, how many degrees are in a 4-sided figure? 4 sides minus 2 would be 2, and 2 times 180 is 360. So this figure has 360 degrees. So if we know that we have 360 degrees altogether, let's subtract out the pieces that we know. 360 degrees minus 65 would be 295. 295 subtracted by 89 would be 206. 206 minus 82 would give us a remainder of, well, in our answer, 124 degrees. So in this case, we can discover that x equals 124 degrees just based on our rule. And once again, our rule was the amount of sides minus 2 times 180. And that right there gives you your total degrees. And then you just have to work backwards, subtracting the pieces that you know.